So if I go to problem number 15, it says determine graphically the local minimum and local maximum of f of x equals negative 4x to the 2/3 minus 3. So now for this one I'm going to use my graphing calculator because that's what you would use to take the ACT test. So we're going to try to do that. So what was that graph again? It was 4 minus 4, so I say negative 4 x raised to the 2 divided by 3. Now pay close attention as to how Mr. Adams enters it in your calculator. Minus 3. So I'm going to hit graph just to kind of look and see what that looks like. Looks like we have a cusp. There's something going on right here. And it says determine graphically the local minimum and local maximum of this. And so if I were to zoom out, I'm going to zoom out one time just to see what it looks like from a bigger perspective. Okay. So now what I'm going to do is I'm going to zoom in and see what's going on at that little point there. See this little point here? I'm going to zoom in closer to kind of get an idea, because it looks like it does like some little loop-de-loop thing. Okay? So I'm not quite sure, so I'm going to zoom in one more time. Right there. And it looks like it just comes to a point. So if I look at the trace and I come from this direction, it looks like my maximum value is when x equals 0, y equals negative 3. Okay? And then what would the minimum value be? What's the lowest y value you could have? Negative infinity, because it looks like if I go in this direction it goes down forever, and if I go in the other direction, if I think in terms of the y values, it looks like it goes down forever. So what do you guys, what would you choose, A, B, C, or D?
C.
C, it looks like it. Uh-oh.
What? I was going off what you said.
Wait.
Uh-oh.
Mr. Adams,
Let's go with B. Try B.
No. Wait. Shh. Hold on. We're talking about the y value. At no point in time does the y value even come close to 0. Does it? No.
Let's go with A.
Now, we'll go with D. Now, Mr. Adams did that on purpose. Why is it D and not C? Can somebody tell me? Yes.
Because there's no local minimum.
The key word is local. The key word is local. Now, the minimum value y, it does approach infinity, but infinity isn't a number, right? So when we talk about local minimum, what we're really referring to is what is the y value its lowest. Okay? So when we say what's a local minimum, we're talking about a point on the curve. Well, there isn't a point that has an infinity. So we could say that it approaches infinity if we study the end behavior of the graph. We could say it looks like it approaches infinity if we study the behavior as it approaches a particular x. We could say that the range approaches negative infinity. We could say all those things, but when we say local minimum, we're really looking for an x and a corresponding y value. So that technically D is the correct answer. Okay? So keep that in mind.